R3D3 RAMA3D program is dedicated to static calculations of 2- and 3-dimensional bar constructions, as well as to the dimensioning of bar elements made of steel, wood, and reinforced concrete according to Eurocodes. An example of modeling a simple steel 3D hull with a truss beam. Having defined the cross-sections, we can start the design with the insertion of a truss beam using one of the generators of typical constructions, a generator of plain trusses in this case. In the bottom far nodes of the truss, we are adding 2 main columns, both 5 meters tall. Using a window, we are selecting the bottom nodes of the columns and ticking the appropriate displacement and rotation locks, thus creating rigid supports of the columns. We are selecting the lower and upper parts of the main columns of the hull. We are changing their cross-section to H-beams and providing continuity in the place of their connection. We are selecting the entire 2D layout and, using the option of multiple copying with dragging, we are creating a 3D layout of the hull. We are changing the view from the perspective to the orthographic projection. Using windows, we are selecting the bottom nodes of the truss and we are deleting the redundant bottom beams that have been created while copying. Again, we are setting the view to front view in the orthographic projection. Using a window, we are selecting the upper nodes of the truss. With them, we are selecting all purlins and providing the continuity along the hull. We are selecting all elements of the hull, except the bars at the level of the upper beams, and we are hiding the selected part of the frame. We are changing the view to top view, and using the Entity Snaps option, we are inserting roof bracing with the aid of joint bars or tie rods. We are inserting roof bracing only in half of the roof, while the remaining ones we are creating through multiple mirroring of the previously inserted elements. We are restoring the view of the entire layout, and then, using a window, we are selecting all elements from the line of the ridge on the right side of the hull. Afterwards, we are hiding them again. We are rotating the view, and we are setting the spatial mode of inserting elements. Using the Entity Snaps option, we are inserting vertical bracing in the ridge and, after restoring the view of a whole layout, also in the lines of the side walls with the aid of the appropriate joint bars. After selecting the option of inserting joint bars and selecting the appropriate cross-section, we are moving to modeling the vertical portal bracing in the far areas of the hull. Here we are using the option of inserting an element of given length in the direction of a selected vector. After inserting half of a bracing, we are using the remaining elements of portal bracing through multiple mirroring of the previously inserted elements.
Please take your leg into the sound of the post.
Examples of other designs. A hybrid steel and wood building. Wooden roof truss. A steel variable geometry hull. A steel haul with a moving load from an overhead traveling crane. A steel geodesic dome with model surface loads.
Wish to leave a record of your call? Please state your message with the sound of the tone.
Structural steel roofing. A mining tower loaded with temperature and support settlements, among others. A 100-meter truss tower with ties.